Hi, today we are going to be talking about categorical data and how we can represent that data in different kinds of graphs. So categorical data is representing qualitative data. So an example of a qualitative data is something that you can put in a category. For example, we can talk about different eye color, easy hair color, other kinds of things that we can put in color categories, types of music, types of candy, etc. So anything that we can put in a group together. When you are representing categorical data, we can use a pie chart, and we can also use bar graphs. The first one we're going to look at is different kinds of pie charts. They are used to display categorical data, as we said. The size of each slice is going to correspond to its relative frequency. And relative frequency is just a fancy way of saying probability. Useful when looking at the sum of all categories to represent the whole. We use it if there aren't too many categories, because if you try to take a circle and divide it into 30, 40 different categories, all of a sudden the slices of the pie get really, really tiny and it's hard to see that relationship. So what we're going to do is we're going to create a pie chart using different colors of Skittles. So to make the pie chart, we have to look at some more information than just the count of the Skittles, because remember we said that each slice is going to represent the relative frequency of that pie chart. So when we look in here, we see that there are 15 red, 25 purple, 20 green, 30 yellow, 10 orange. If we want to look at the probability of each of those colors, we need to find the total. So 15 plus 25 plus 20 plus 30 plus 10, we find that the total is going to be 100. So if I want to calculate the relative frequency, get another chart down here, we see that we have 15 red. So there's 15 out of 100, which gives us 0.15. Now, how that relates to our pie graph, our circle here, we are going to take 15% of the circle. And if we're looking at the whole circle, we know that a circle has 360 degrees. So we're finding 15% of that whole circle, which is going to make up 54 degrees. We look at purple. There are 25 out of the total 100, which gives us 0.25, 1/4. So we find 25% of that whole circle, which is 90 degrees. Green accounts for 20 of the 100, which is 0.2. So we're trying to find 20% of the whole circle, which gives us 72 degrees. There are 30 yellow, which is going to be 30% of our circle, which is going to give us 108 degrees. And last, there are only 10 orange, making up 10% of our circle. So again, 10% of 360 is going to give us 36 degrees. Again, remember we just added all those up and we know that we have a total of 100 count. If I were to add up all of the decimals, it would add up to 1, because remember we moved the decimal 2 spots, which would give us that 100%. If I were to add up all of the degrees in this case, we end up with the full circle of 360 degrees. Now, when we go to make our pie chart, we want to make it as accurate as possible. So the first thing I'm going to do is I'm going to look for any easy ones. And I see that there's 90% for purple. That one is probably the easiest one for us to graph because we know what our 90% is going to look like. So we have our purple purple section right here. We're going to label that 25% is going to be purple. Now if I look at the other ones, not as easy, but we want to make sure that we kind of put everything into perspective. So if we just go back to red, red is 54%, so more than halfway, because we know that if we look at the other half of our circle, this imaginary line, don't draw that, but we know this is 90 degrees. So if I want to go, halfway would be 45, so I want to go a little bit more than halfway. We want to make it as close as we possibly can without having to do too much extra work. So we see that this is going to be our red section, and 15% is going to be red. Now I'm going to skip the 72 for right now, because if I look at 54 and 36, that adds up to be 90, right? So that's going to be the other portion of that, and that 36 is orange. So again, that's the other half of that 90 degrees. Each one gets its own little pattern here. We'll go over that in just a second. So we've got 10% as orange. And so the only two we have left are green and yellow. So we see green is 72%. Oops. Just have green. So again, you want to think about if this is as much as 90, we're not quite at 90. So this is going to be our green. And I'm not going to give that anything. Green is going to be 20%. And then the last section here is our yellow. And we see that yellow is accounting for 30%. So now I color coordinated all of my different sections. So I used purple for purple, red for red, orange for orange. But if you don't have all those colors, what you're going to do is you're going to create a legend, or a little scale to tell you what everything is when you don't have all those colors for you. If you have all the colors, then you don't have to worry about that. So first we have the stripes was purple. Our dots were red. The checkered pattern was orange. Green was just empty. And then we had our yellow highlight. So not only do you have to be able to create the graphs, you also want to be able to interpret the graphs. So if you wanted to make some general observations about what you see in the pie chart gives us a good visual of the relationships. So one thing that I see right off the bat is that we have yellow was the most common color. I also see that orange was the smallest slice, so orange was the least common color. So pie charts are really good for showing those obvious relationships. Gives you that visual. All right, so that's our pie charts. We also have categorical data being used to show with bar graphs. The bar graphs should have equal length for meaningful comparison. So I'm not going to change the width of the bars. The horizontal axis is going to represent the different categories. And the vertical axes can be the frequency, which is the count, or the relative frequency, which is the probability. Alright, so it doesn't matter if you're using count or probability, but you just have to label. So we have our Skittles, And again, there's the chart, so we don't have to flip over to the first side. It said on the x-axis, so going horizontally, we're going to have our category. So in this case, our category is Skittle colors. And our first one is going to be frequency, or the count. We have all of our different categories. The first one we have is 15, the largest is 30. So when I'm going to create my labels on the vertical axis, I know that the highest number I have to go up to is 30. And then I kind of break it down from there. We see that we're really going to multiples of 5. So I'm going to break that into 3 equal pieces. So that gives us 10 and 20. And then I break each of those in half, 5, 15, 25. That way you don't have to worry about equally spacing as much if you break it down smaller and smaller and smaller. So our first one is red. So we have red, and there are 15 red. And the next we have is purple. We have 25 purple. So we go all the way up to 25. And when it talked about having the equal length, it's that equal width. So we're just going to make sure that we're using the same kind of bar. Obviously, the purple is going to go higher than the red because we have more purple. Next is green. And we have 20 green. If you're ever not quite sure and you want to do some extra, just write the number on top of it so you can be clear about what the number is supposed to represent. We've got yellow is going all the way up to 30. And then orange, we only have 10. And that's as easy as a bar graph is. Again, the x-axis, you want to make sure that you label everything, give it a title. The title was provided for you already, Skittle colors. The x-axis we label with whatever category we have. And on the left here we have frequency. So what you're going to do now is you're going to press pause, and I want you to do the next one. And we're using relative frequency for this one, which we found on the front page. Remember, that's just the probability. It was 15 over 100, which is giving us 0.15. So the only difference is on the y-axis here, you're going to label it with relative frequency. Okay, so go ahead and push pause. So when you're done creating your relative frequency bar chart, you realize that it's the exact same. Everything looks the exact same as it did with the frequency. So it really doesn't matter if you do frequency or relative frequency. You get the same result in the end. All right, so just a couple little questions. Again, we want to be able to read the charts as well as create them. What Skittle color seems to appear the most in a bag of Skittles? Really easy visual, we can see that yellow is the highest bar. Therefore, yellow is probably the most common color. Would it be safe to say that all bags have the same amount? No. You know, when it comes to Skittles or M&Ms, when you open up any bag, it's going to be a random assortment. So we can't make that generalization about every single bag. That's something that's really important about stats. Would our numbers be the same if we had a smaller bag? No. If you remember from the PowerPoint, sample size is really important. If you have a small sample size, it's going to most likely be skewed. As your sample size gets larger and larger and larger, your true values will become more accurate. All right, and that is it for categorical data and its graphs.